Hi students, in this class we shall be discussing coefficient of concurrent deviations, which is the fourth different method of correlation analysis. So let us try to understand what it is through an example. Okay, so this is a very simple and casual method. It is a very simple and casual method of finding correlation when we are not serious about the magnitude of the two variables. We are not interested in the value of correlation, but yes, we are interested in the sign of the correlation. Okay, whether it is positive or negative, that's what we are concerned with. Okay, whether there is an increasing trend or whether there is a decreasing trend, that's it. That is what we are trying to understand or find out using coefficient of concurrent deviations. Okay, so this is a very simple and very casual method of finding correlation. Okay, for finding correlation when we are not serious about the magnitude of the two variables, Okay, so let us understand this thing through an example. Okay, and what are the processes involved. So let me consider a given series as say x is given to you as the list will be like this, say 10, this next is 20, then we have 15, then 18, then 32, then 30. Okay. Next what we have is the y. Okay, y. What is y? Let me list down the numbers. That this is 8, then we have 11, then 22, 17, then 19, and then finally we have 24. Okay, so what happens here, this is the data given to you. Okay, this is the data given to you. X is given here, y is given here. Okay, now we are interested in the type of change that occurs in each of the series. Okay, so in X series we will observe that. So look here, read. Okay, what happens? This method involves in attaching a positive sign for an X value except the first. Okay, except the first if this value is more than the previous value, and assigning a negative value if this value is less than the previous value. Let us understand this thing. Okay, how to do this. Okay, here when we observe that, see, when we don't do anything for the first value, we don't do anything for the except the first, means for the first value we don't attach any sign. Now we observe what kind of change occurs with the next one. So from 10 it increases to 20. So what happened? Increase happened. Okay, so what kind of change? A positive change. Okay, the change sign is represented to the second variable. Now from here to here, 20 to 15, what happened? Decrease happened. So we put a minus sign. So this is nothing. Okay, this is nothing, dash, not a minus sign. Here also we don't do anything for the first case. We don't put any entries. Okay. Same way, 15 to 18 is an increase, 18 to 32 is an increase. Okay, again 32 to 30 is a decrease. Okay, so what happens in the first step? We assign signs to each value except the first one. Okay, and the sign will be the indicating the type of change. This sign indicates that it has increased to 20. This sign detects, or this sign tells us that it is decreasing from some number to 15. Okay, positive change means 15 to 18 is increasing. Okay, like that. Now here what happens? It is very simple. 8 to 11 positive, 11 to 22 again positive. Then what we have is 17 to 19. 17 to 19 is also positive. 17 to 19 is positive. 22 to 17 is negative, and 19 to 24 is also positive. Okay, now what we are supposed to do? See, we have already done that for the Y series also. This is the X series and this is the Y series. For Y series also we have assigned the sign. So the second step is also done. Next step is that the deviation in the X value and the corresponding Y value is known to be concurrent. if both the deviations have the same sign. Okay, what we do is we find out if the deviations are concurrent, then we assign a positive sign. Okay, so these are two columns. So we get two columns. Which two columns? Column A and column B. Okay, column A represents the sign of the deviations. Column A represents the sign of deviations from the previous value. Okay, same way column B represents the sign of deviations from the previous value for y. Okay, we can draw a line like this. Now, what we are interested here is, okay, this is also nothing. We don't write anything in the first part. Now, here we need to find out the product AB, the product of the signs. So, plus into plus is plus, so they are concurrent, and here they are not concurrent, so the negative. If they are different signs, we have a negative sign. If they have positive sign, then we have a positive sign. Okay, or if both of them are negative, then also we get positive sign. Here in this case, we are not getting anything like that. If both the signs are same, identical for x and y, see for the first one and the first one in B, first one in A and first one in B, we have positive signs. So therefore the output is positive. Okay, so here minus, here plus. So minus into plus is minus. So different signs will give you a negative sign, different signs will give you a negative sign, same signs will give you a positive sign. Even if it is both of them are negative, we will get a positive sign. Okay, this is what we do. Okay, now this is what we keep, and then we have another formula. Okay, what is the formula? Let us look at the formula first of all. So here in this formula, what we have is, here what we have is the coefficient of concurrent deviation. The formula for coefficient of concurrent deviation is given, that RC, it is denoted by RC. R is coefficient of correlation, of concurrent correlation. Okay, now here the formula is RC will be equal to plus or minus under root of plus or minus again into bracket 2C minus M divided by M, 2C minus M divided by M. Okay, where C represents the number of concurrent deviations. C represents the number of concurrent deviations. M represents the total number of deviations, that is total number of pairs minus 1, total number of pairs minus 1. Okay, okay, in this case, if 2C minus M is positive, if in this bracket whatever value 2C minus M is positive, then we take positive sign both inside and outside, otherwise we take minus sign both inside and outside. This is because inside the root of a negative number is not defined, so whatever we have inside the root should be made positive. So if we are making a negative sign inside, we will take one outside also. If we are taking a positive sign inside, we take a positive sign outside. That's it. Okay. Now the coefficient of concurrent deviation lies between minus 1 and 1. So let us try to understand and apply this formula into the problem. Okay. So let us understand what is M, what is N in the previous case. Okay. Here what we do is we have found out AB. So we had RC equal to plus or minus under root of, okay, 2C minus M divided by 2C minus M divided by M. Here again plus or minus. Okay, where C was number of concurrent deviations, number of concurrent deviations. How many concurrent deviations are there? The number of positive signs, 1 positive, 2 positive. So the number of concurrent deviations is 2. So this is equal to 2. Okay. Now what is M? M is the number of pairs. Now what is M? M is equal to number of pairs. Now M is the number of pairs of deviation. Okay, number of pairs of deviation. Now what is M here? Number of pairs of deviation, that is total. We take it as n minus 1, total number of pairs. This is 1 pair, 2 pair, 3 pair, 4 pair, 5 pair and 6 pair. So here in this case we have 6 minus 1, that is equal to 5. So we put all these values inside. So we take plus minus square root of, again plus minus, we find out 2c minus m. What is 2c? 2 into 2 is 4 minus 5 divided by 5. Okay, this value will be negative. What we get here is this will be equal to plus or minus under root of plus or minus, this is minus 1 by 5. This is minus 1 by 5. So inner value is negative, so we take negative on both sides. So we have minus of under root of minus 1 by 5. Okay, so that is equal to minus square root of 1 by 5. This will be your answer. This can be calculated. Okay, or minus 1 by, that will be equal to minus 1 by root of 5. This is your answer. We can calculate, find root 5 and divide minus 1. Okay, so now let us consider the properties. Okay, well, there is only one property, that the value of concurrent deviation also lies between minus 1 and 1, both inclusive. It can have minus 1 as a value or 1 as a value also, and between 1 and minus 1 also. Okay, now let us consider one more problem, how to solve coefficient of concurrent deviations, or how to find out coefficient of concurrent deviations. Okay, let's look at the following problem. Find the coefficient of concurrent deviations from the following data, and the data is given. Okay, we have two variables, x and y. Okay, price is taken as x and demand is taken as y. So the data is being put into a table like this, and we prepare a table like this. So the titles will be nicely written like this. Okay, now we cancel this off. This is cancelled. This place is cancelled. Okay, now what kind of change is here? What kind of change? 25 to 28. 25 to 28 is an increase. 25 to 28 is an increase. Okay, now 28 to 30 is also an increase. 30 to 23. 30 to 23 is a decrease. 30 to 23 is a decrease. 23 to 35. 23 to 35 is an increase. Okay, now 35 to 38 is also an increase. 38 to 39 is also an increase. 39 to 42 is also an increase. So therefore we have signs like this. Okay, next in the same thing we will do for y column also. So 35 to 34, it is a decrease. 35 to 34 is a decrease. Now 34 to 35 is an increase. 35 to 30 is a decrease. 30 to 29 is a decrease. 29 to 28 is also a decrease. 28 to 26 is again a decrease. 26 to this one is also a decrease. Okay, now we shall take the product of the signs. Okay, and write it on the other side. So plus into minus will be minus. Plus into plus will be plus. Minus into minus will be minus. See, same signs, so plus. Okay, sorry, same sign, then we have a plus sign. Same sign, then we have a plus sign. If it is different signs, then we have a negative sign. This column is also not used anywhere. Okay, plus minus remaining everywhere we have a negative sign. Okay, so therefore we can directly get the number of concurrent deviations. What is the number of concurrent deviations? Number of concurrent deviations will be the number of positive signs here. Number of positive signs will be equal to concurrent deviations, this one and this one, positive. There are two concurrent deviations. Now number of pairs, how many number of pairs? This is 1 pair, 2 pair, 3 pair, 4 pair, 5 pair, 6 pair, 7 pair and 8 pair. So there are 8 pairs. So what we have here is 7. Okay, n minus 1, that is m. Okay, now we find it 2c minus m. We put everything into this formula. Okay, we have all the values. We have found out the number of positive signs and number of deviations also. So we shall put all values into the formula. So it is plus or minus square root of again plus or minus. This is 2 into what is c? C is also 2. 2 into 2 minus m. M is equal to 7 divided by 7. Okay, so this will be equal to plus or minus square root of this is 4 minus 7, 4 minus 7 plus minus, okay, numerator is 4 minus 7. What is 4 minus 7? 3. So it is minus of 3. Okay, so here inside we have a negative sign, so both here and here we will take a negative sign. So what we have is, see, what we have here is minus of square root of negative 3 by 7. Okay, so finally we have negative square root of 3 by 7. This can be calculated. Okay, this can be calculated, and here there is a negative correlation between price and demand. Okay, so what this says that we are interested in the sign of the rank correlation. Sorry, we are interested in the sign of the of this value, sign of correlation. Okay, we will say that the price and demand are negatively correlated. The value is negative. Okay, so therefore the price and demand. Okay, demand. These are the two variables. Okay, price and demand are the two variables. One is x, the other one is y. Okay, price and demand are negatively correlated. Okay, because this value is less than 0. That's it. Okay, so thank you. All problems will be of this type only. Okay, thank you.